Greetings, traveler. I'm the calculus cleric. So the specific question is evaluate the integral. So the integral is x squared over x squared plus 9. And so we have to find the antiderivative of that. And to get started, well, when we do the method of partial fractions, we take a look at the bottom because it's some complicated number that you can't really easily solve with any of the other tricks. It's not something you already know and memorize. And so you break it up. But if you notice x squared plus 9, you can't really break that up into anything. So we actually can't use the method of partial fractions for this one. We use something called long division. So long division is basically we just divide. And the only thing that can really fit is a 1. That's the only thing that's really going to cancel out anything. I'm going to multiply the negatives, becomes that. And then these two cancel out to 0, and then we're left with negative 9. So we just want to get rid of the x squareds. We don't want to overcomplicate anything by adding in more constants. Well, that's a remainder. We can rewrite that as negative 9 over x squared plus 9. And then rewriting the integral, because this just breaks down into that. And so what we did was we got rid of the messy x squared on the top. So this part is fine. That will come out to something, so we don't need to worry about it. So we only need to specifically look at this. Let's just separate it out for now. So we need to find a u substitution that will be able to get rid of the bottom and turn it into a regular antiderivative, but once again, we don't know what this can break down into. So let's assess our avenues and figure out what this looks closest to. For me, I think it looks closest to this. Tan to the negative 1, or arctan. So how are we going to get x squared plus 9 to equal x squared plus 1? Well, the fastest way to do that is to divide everything by 9 so we can change this 9 into a 1. So that breaks down to that, and then this simplifies out to 1. That simplifies out to 1. So we're left with 1 over x squared over 9 plus 1. Now, we don't want x squared over 9 either because we can't really turn that into a u. To get there, we need to change this into something that can be isolated from the squared symbol itself. 9 can be broken up into 3 squared, and then so we can have x over 3 squared plus 1 on the bottom. And so now we found our u. And we set our u equal to x over 3. Du is equal to 1/3 dx, and then dx will be equal to 3 du. And then from there, we just plug it all back in. 1 over u squared plus 1, and then du, and then multiply this by 3. And then from there, 1 over u squared plus 1, as we stated earlier, is tan to the negative 1. Okay, so now we get this. We plug that back into there. And so we're going to have 1 negative 3 1 over u squared plus 1 du. And the dx stays on the 1. And so let's solve that part first, since it's the easiest. Antiderivative of 1 is just x. And then negative 3, and as we stated earlier, 1 over u squared plus 1 is tan to the negative 1. And then plus c, because we don't have any bounds. So there's no numbers here or there. And then we have to replace the u with what we originally substituted out for. So that's x negative 3, tan to the negative 1, x over 3 plus c, and that is going to be our final answer.